Our world is rife with mysteries and enigmas. Through the years, a myriad of wondrous events have occurred and thousands of amazing discoveries have been made. We can never be quite sure what lies beyond the horizon. Between archaeological wonders and the rapid development of technology, there is an unbound potential for our future. So today, here at Unexplained Mysteries, we'll be taking a look at recent discoveries. Physicists detect ghost particles in the Large Hadron Collider for the very first time. Particle physics may not sound like the most interesting concept, but there are some fascinating developments happening in the field as of late November 2021, bound to pique the interest of even the least scientifically minded among us. Particle physics aims to gain insight into the universe by looking at the smallest units we can in order to gain an insight as to how things work on a much larger scale. However, not all particles are made equal. Some are much more elusive and much trickier to study than others, making them all the more exciting. Back in school, you might have discussed subatomic particles, looking at electrons with a negative charge, protons with a positive charge, and neutrons with no charge, all found within an atom. Well, a neutrino is not too dissimilar to this. Neutrinos are subatomic particles that are fairly similar to electrons. However, they differ in two key ways. They have no electrical charge, and their mass is so minuscule that it could even be considered to be zero. What is most unique about neutrinos is the sheer quantity of them. We have billions of them moving through each one of us right now. They are the single most abundant particle in the universe. However, despite the huge numbers and them moving through the universe at quite literally the speed of light, it is very rare that a neutrino interacts with any sort of matter, making them incredibly difficult to detect. Due to their hard-to-prove nature, but us knowing that they are there, they have earned the nickname ghost particles, though their supernatural status may be diminishing in light of a new study. The Large Hadron Collider, the most recent addition to the CERN accelerator complex, is the world's largest and most powerful particle accelerator. It works through superconducting magnets and is based in the European Organization for Nuclear Research in Switzerland. Jonathan Feng, a physicist with the University of California, Irvine, the co-leader of the Phaser collaboration, said, "Prior to this project, no sign of neutrinos had ever been seen at a particle collider. 6 neutrino interactions were detected by the collider and were spotted using the neutrino subdetector, Phaser Nu. This research shows us the sheer capability of the $4.75 billion machine and opens up new doors for researching the little-known neutrinos at such high energies, hopefully letting us continue to dive deeper into their roles, purpose, and structure. While we have not detected neutrinos in any particle collider before now, we have managed to see them interact very rarely in some other circumstances, namely Ice Cube, found in America, Super Kamiokande, in a Japanese research project, and Mini Boon at Fermilab, Illinois. These all used highly sensitive photodetector arrays. When a neutrino interacts with other particles in entirely dark environments, light is produced in what is often described as a shower of light. This light is what the photodetector arrays can pick up on in the rare instance that neutrinos do interact. While this research is great, there are of course limits in how much we can learn from this. The next step was to try to study the ghost particles in particle colliders. The collider neutrons, produced from the decay of hadrons, have extremely high energies. The ghost particles are not well documented as it is, but the study of them at high energies is even more limited. The subdetector used, Phaser Nu, is an emulsion detector. This means that plates of lead and tungsten are fitted with a layer of emulsion in between. The neutrinos then collide with the nuclei of the lead and tungsten plates. The particles produced here leave evidence behind in the emulsion layers that can then be observed. The plates develop in a manner likened to photographic film developing. Then the traces left in the plates are available for analysis, with tracks left like footprints of the neutrinos. After determining that the particles observed were indeed neutrinos, the science does not stop there. There are different neutrino varieties, electron, muon, and tau, as well as antineutrinos. With more developments in the works at CERN, it is hoped that the next stages of detecting neutrinos is in the not-too-distant future. Furthermore, scientists hope that similar processes and technology could lead them to signs of even more difficult things to detect, like dark photons, a hypothetical component that aids in the explanation of dark matter. So many black holes. We are quite used to seeing amazing images taken of the night sky. Whether from typical cameras or special astronomical equipment, we are all familiar with huge black panoramas decorated in thousands, if not millions, of little white dots. From movies to textbooks, and even simply staring up to the night sky, it is a scene that we have all seen countless times. But scientists at the University of Hamburg have created such an image with a bit of a different background. The image, which shows a wedge of space covered in thousands of white spots, is actually a photograph of thousands of supermassive black holes. That's right, every last one of those stars is actually a supermassive black hole sitting at the heart of a galaxy. Totaling years of accumulating work, the researchers have succeeded in making the most detailed map of black holes at low radio frequencies to date. The team used innovative techniques to create the image, specifically a method of converting radio signals into images of the sky. The difficulty in photographing black holes lies in, well, their color. The black holes themselves are void of anything perceptible, and scientists rely on the after effects of the black hole's behavior to detect them. When a black hole is feeding, then the accreting material spooling off from nearby planets, stars, and other objects is a telltale sign. The team used an impressive tech setup to take the photo, specifically the low-frequency array in Europe. Built across the whole span of Europe, the network of tech is made up of 20,000 individual radio antennas over 52 locations. LOFAR is currently the only network of its kind, and no other network can offer the same sort of imaging of the sky. The now famous photo was taken using frequencies below 100 MHz and is only 4% of the northern sky. Ultimately, the plan is to map the entirety of the northern sky through the LOFAR LBA Sky Survey. As the methods and network improve based upon this first stage of development, researchers hope that they will gain new data on celestial objects, eventually measuring objects beneath 50 MHz. The Bortez Void. While it is exciting to imagine the universe as a vast, bright expanse lit by stars and other celestial objects, that is not always the case. 700 million light-years away from Earth is a large, spherical region of space with very few galaxies. This is the Bortez Void, and it is exciting in a much darker way. The sphere, which is about 330 million light-years wide, is large enough to hold billions of Milky Ways, yet there is hardly any galaxies to be seen. It was discovered in 1981 when Robert Kirshner and other astronomers were working to create a 3D map of the universe. Originally, the region was called the Great Nothing, but it was ultimately given the name the Bortez Void because it appears to lie in the Bortez constellation. The Bortez Void is not the only void in the universe. Galaxies exist in a web-like arrangement inside large thread-like structures called filaments. Voids exist in between these filaments, and they make up about 80% of the observable universe. Typically, voids measure between 30 to 300 million light-years across. Bortez, however, is one of the largest, and it has even earned the title of supervoid. Scientists have discovered only 60 galaxies in the Bortez Void. Based on the average distance between galaxies, the void should contain around 10,000 galaxies. According to astronomer Greg Aldering, if the Milky Way had been in the center of the Bortez Void, he wouldn't have known there was other galaxies until the 60s. Astronomers believe that voids are created due to random quantum fluctuations that occurred in the early days of the universe and led to small differences in the distribution of matter. In more dense areas, the gravitational pull was stronger, which forced matter away from less dense areas. This created a cycle that led to the areas becoming more and more dense, and eventually clumps of matter became galaxies. At the same time, voids were created as matter was pulled away from low-density areas. This process theoretically explains most of the voids, but it does not quite explain the size of supervoids like Bortez. Scientists are not convinced that gravitational forces alone could practically empty a space of that size. A new theory suggests that it is possible the supervoid is made of multiple smaller voids that have merged together. Astronomer Greg Oldering observed tube-shaped galaxies inside the supervoid. He interpreted the tubes as representing previous boundaries between smaller voids. Although plausible explanations for the Bortez void exist, the supervoid has still challenged standard ideas of galaxy formation. Luckily, Bortez and other voids may help astronomers learn more about the origins of the universe. And, since the Bortez void is nearly a vacuum, it may one day present an opportunity for super-speed space travel. Perhaps the most important implication of the Bortez discovery is that it may prompt scientists to revise the Big Bang theory, as no one is quite sure how the existence of supervoids fits into our current ideas of gravity and quantum mechanics. Scientists want to store DNA of 6.7 million species on the Moon. A group of researchers have proposed what has been described as a Lunar Ark, which, if ever executed, would see vast amounts of Earth's genetic material stored on the Moon in case of a cataclysmic event planetside. Almost like a biological save state, the project would involve the creation of a vault to store and house material of Earth's 6.7 million species of plants, animals, and fungi. One of the head concept leaders on the project, Tanga, said the following: "Earth is naturally a volatile environment. As humans, we had a close call about 75,000 years ago with the Toba supervolcanic eruption, which caused a 1,000-year cooling period and, according to some, aligns with an estimated drop in human diversity." Tanga is an aerospace researcher at the University of Arizona and pointed out that genetic material banks are already a thing here on Earth, such as the Svalbard Seed Vault in Norway. Yet these terrestrial banks could be jeopardized by climate change, conflict, or celestial events. Tanga went on to say that the risk factor actually defeats the purpose of these banks, and ensuring that there is a genetic ark on another celestial body, be it moon or planet, was vital. Though an exciting idea, this project would not be cheap, as it would require a significant construction project inside of our moon's hollow lava tubes. The walls of these tubes would help to protect the Ark from environmental dangers as well as meteor strikes. The temperatures would also be useful for storage, as these hollow areas typically sit at around -15 degrees Celsius. Tanga is hopeful that we may seriously be able to consider the construction of such an Ark in the next 30 years, as space travel becomes more viable. But what do you make of these recent discoveries? Be sure to let us know your thoughts in the comment section below and help us grow this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.